Hello everyone. Today I am going to share with you on how you can create these pressure vectors on your airfoil or whatever geometry that you may have. Pressure vectors are helpful to illustrate how pressure forces are acting on our body of interest. So let's get started. Okay, here I've prepared for you a simulation using the E420 airfoil. The solution has converged. Okay, I'm sure that we are pretty familiar with this formula. We have the variable AF, and then we have the X phase area to the second power plus Y phase area to the second power. We don't have Z since this is a 2D environment. And then everything to the power of 0.5 square root. So, and then we have AX, which is the unit vector, just X phase area divided by AF, the variable earlier. Same thing for Y. This is the way that we can get our unit vector. Okay, now, first thing first, you can go under the user defined tab, select custom, and now we are going to include the formula earlier. This is to get AF, X phase area square plus Y phase area square to the power of half. So I can use double bracket, go to mesh, and select X phase area. Oops, delete. You have to select, okay, X phase area to the power of 2, close your bracket, plus Y phase area. Before that, include the open bracket, Y phase area to the second power. Okay, close your bracket again, to the power of 0.5. Okay, then you can include the name of the variable AF and define. Okay, the first step is done. Now clear. Next step is to get AX, X phase area over AF. So you just go to mesh, X phase area, select, divided by your new custom field function will come inside here, custom field function. Okay, select that one, and your AF is there. Select. So your new function name will be X. Define. Do the same thing for your Y phase area. Clear, mesh, Y phase area, select, divided by custom field function AF. Select Y. Okay, next, we are interested with the CP vectors, right? So we already have the unit vector. Now you just multiply the X component, select, times the pressure coefficient. We will name this as CPX. Define. Clear, pressure coefficient, select, times the unit vector of Y, select CPY. And as easy as that, define, can close the window. Next, we can go under results, graphics, results, graphic, vectors. Okay, you can go to custom vectors. Okay, the X component should be CPX under custom field function. CPX, Y under custom field function, CPY. Let's name it as CP vectors. Okay, define, close. Okay, you can draw the mesh first. Okay, change. I can select all parts of the airfoil. Change the color. For a wall, I would like it to be black. Close, display. Okay, my outlet is still here, so I have to uncheck it. Okay, uncheck outlet. Now close the window, zoom into the airfoil. Okay, CP vectors is correct. Color by, I'll change it to pressure coefficient. And then change, since this is a 2D environment, fill vectors. Okay, we are interested with the pressure vectors on the airfoil, right? So we have to select all components of the airfoil, hose, walls, lower, upper. Okay, save display. Okay, it is nothing because the value is very small. We can scale it up to 150. Display. Ta-da! Okay, so this is your pressure vectors. Now I can just right click full screen. Okay. If I zoom in near the leading edge, you see that this region here is a negative CP. But it's better if I also include the XY plot of CP. My chord length is 0.3 meters. Okay. If I want to illustrate it as if it is X by C, what I can do is just 1 divided by 0.3. So I can get 3.333. So I'll just keep the n into my X value. So now the total length will be 1. So this is as if I'm illustrating the data in terms of X by C. Okay, this is on the low surface. Can you snip? Okay. Now this is the value of pressure coefficient of 0. It is at maybe 0.15. And there's only one point of intersection, which is here. Okay, whatever that is before X by C 0.15, it is negative CP. So pressure is moving outwards. And then downstream of X by C 0.15, it is towards the airfoil. Okay, so this is a better way to illustrate our data of CP. Another good thing is that, as I mentioned before, we can understand how pressure forces are acting on the airfoil, such that, let's say, for example, from this point to this point here, the pressure forces are contributing towards drag. But from this point here, this is CP0 on the upper surface. It is contributing towards negative drag or thrust up to this point here, where this line is vertical. And this one is contributing towards drag. Same thing on the lower surface. This one is towards thrust. And then there will be some point here where this is vertical. So this is towards to the left. This is towards thrust. Now there is a component of drag here until CP0. And then this one is towards the left also. It has a component to the left. So this is thrust. And then up to one point here where the line is going vertical, where it separates the pressure vectors going to the left or to the right. So the remaining part here will contribute to the to drag. Okay, I hope that this tutorial is helpful for you to understand how pressure forces are acting on the airfoil, and hopefully you like it. Thank you.